Hi, have you ever considered that the majority of the machining tasks is based on repetitive movements? I'm Alexandros Chiassos, and today we're gonna learn how to use G91 in order to program repetitive movements. Okay, first of all, let's begin with an example about G91 so as to better understand its use. G91 is a model command and stands for incremental positioning. Once activated, stays active until a G90 command cancels it, where G90 command stands for absolute positioning. So now let's begin with this example. Let's say that we want to go from point 1 to point 2 to point 3, then to point 4 and back to point 1. And here is our origin. Incremental positioning means that once we are in a known point, we can go incrementally to other points. Let's see this principle in action. So here, the first block says that we go to the origin of our part, x0, y0, following the absolute positioning system. Then we go following a linear motion and switching back to incremental positioning, we go to x0 and y10. This means that x-axis won't change and y-axis will go for 10 millimeters. So this means that we go from point 1 to point 2. In order to go to point 3, we have to go from this point 10 millimeters along x-axis. Y-axis won't change. So y-axis will stay 0 and x-axis will increase by 10 millimeters. In order to go from point 3 to point 4, y-axis has to decrease by 10 millimeters and x-axis won't change. And again, if we want to go to the first point, we have to decrease x-axis by 10 millimeters and keep y-axis the same. Note that these words are not necessary. We don't have to write down the axes that their values do not change. Let's now dive into the basic idea of this video. As we've already mentioned, the common machining processes can be considered as a set of repetitive movements. For example, for this process here, which is a face milling, there is the same set of movements that are repeated again and again. Here we go from this point down along z-axis, we go along x-axis, we go up along z-axis, we will move forward to the next y point to the same x point, when we go down along c, along z, and goes on. So there is a basic block that can be programmed in order to automate this process. This is this one. We have a motion from point 1 to point 2, then to point 3 along z-axis. We go along x-axis from point 3 to point 4. We go up from point 4 to point 5 along z-axis, and then we go to point 6, which has the same x coordinate as the point 1, but it's forward along the y-axis in order to take the second pass. And then the same blocks are repeated in order to complete the face milling process. Okay, let's now see the code that we were to program in order to machine this face milling. As you can see here, this set of blocks can define a repetitive task that can be repeated again and again in order to complete this face milling. So, in order to analyze the blocks that we have here, let's say that for beginning we are already in first point. Then we activate the incremental positioning, and then we go down for 10 millimeters, then for 5 millimeters, then we go along x-axis for 100 millimeters, we go up following a rapid movement for 15 millimeters, and then we go back to our new point 1, which is the point 6, and we go back for 100 millimeters along the x-axis and 20 millimeters along the y-axis. And then we go back to the absolute system. This task here can be repeated, can be copied and then pasted again and again for the length of our part. An additional example that can be programmed using Z91 is where we want to machine a circular pocket. Okay, this is not the kind of example that can be machined using identical blocks, but as you can see here, we can see a pattern. We have circles and line, circle and line, circle and line, circle and line, and goes on. As you can see here, the basic two blocks that are repeated again and again is a full circle and a line. The full circle, as you can see, goes from the same point to the same point, respecting the incremental positioning system, and the lines goes up along y-axis for a given value. Okay, this set of blocks can be repeated, but in order to perform this task, this may stay the same, but this value has to be changed every time a new circle has to be programmed, because the circles have a different diameter. To sum up, we can distinguish that we have two kinds of repetitive tasks. The first one refers to those tasks that can be completed by repeating a set of blocks again and again, and no values have to be changed. And the other kind of repetitive tasks refers to the tasks that can be programmed with almost identical blocks, but they have some values that have to change in every block. Okay, that's it for today. Thank you for watching. If you have any questions or any comments, you can comment below. If you like this video, please give us a thumbs up. If you like this video and you want to see more, please subscribe. If you like this video and you want to help this channel grow, please share this video to other social media platforms. And of course, don't forget to go to our website, cncseminars.com, where you can find articles about CNC machining. Bye for now, and see you next time.